I wanted to do a review together of your 1-2 practice. In Canvas, this was set up like a quiz because I wanted it to automatically grade that for me and for you so you could see how you did. Everyone will receive 10 participation points for completing that assignment. I will have to go back in and manually edit those scores. So today I want to do a review of that practice. If you'll get some paper and you will head it up as shown, we will go through those problems together. This is the exact picture that I drew for you in your 1-2 video lecture. It shows under the umbrella of real numbers how numbers can either be rational or irrational. I would like you to copy this into your notes for today, please. I think it's important that we see this over and over and over. And so we're going to use this several times in notes. So please copy this again onto your notes for today. Rational numbers are made up of integers, which are whole numbers, both positive and negative, repeating decimals, and terminating decimals. Irrational numbers are decimals that do not terminate or repeat. So we're going to use this little graphic to help us review the 10 problems that you completed on Tuesday. Question number 1, and you do not have to copy the graphic again, but I would like you to number the question, number 1, and I would like you to write the problem, 6. So for example, you're going to have number 1, and you're going to have 6. And then we're going to write, is it rational or irrational? So you do not have to copy the graphic or write both answer choices, but you are going to number the problem like this, and you are going to write the question like this, and then we'll add the answer. 6. Well, 6 is not a decimal. Do you see how that says decimal? It is not a decimal, so it cannot be irrational. It is also not a decimal or a decimal, but it is a whole number. So I know that 6 is rational. So on your paper, please make sure you have numbered this number 1. You have written the question, which is 6, and the answer, which is rational. Number 2. Again, I have the graphic at the top. We're going to refer to that. You should have drawn that on your paper when we got started. I'm going to write the question, 12.34, and then I'm going to look through my choices. I know this is a decimal, so it is not an integer. I know it is not a repeating decimal because it just stops. There's nothing after the 4. I know this is a terminating decimal because it stops. So this is rational. And let's add that too because it is terminating. So it is rational because it is terminating. Here is question 3. So again, you're going to number your problem, number 3. You are going to write the problem, negative 2.478902 ... Now those dots mean that this goes on. So I'm going to go ahead and eliminate integers. It is not an integer. It is not repeating because it has different digits. And it is not terminating because it does not stop. Those dots tell me it does not stop. So this one is irrational. And I'm not going to write a reason there because there's only one option for irrational numbers. Decimals, which this is. Decimals that do not terminate, which means stop. And I know it doesn't stop because of the dots. Or repeat. And I know it doesn't repeat because all my numbers are different. So this one is irrational. Question 4. So I'm again going to write question 4. Negative 11. This is not a decimal. It is a whole number. So it has to be rational. And it is rational because it is a whole number. So please make sure you have the problem part that I have in black on your paper. Question 5. I'm going to number it number 5 on my paper. 6.8888888 ... I'm going to rule out an integer. This is not an integer. It's not a whole number. It is a decimal. The question is that a repeating decimal, a terminating decimal, or a decimal that doesn't terminate or doesn't repeat? Now, I know these dots mean it continues. However, if I look at the digits, these digits are repeating. The best way to write this would be 6.8 with a line over the 8, which means that that repeats. But if I look at the digits themselves, that 8 is repeating. So this is rational. And I had to write mine down here because I didn't have enough room. And it is rational because it repeats. So my answer is rational. My reason, which is important for you to know, is because it repeats. Number 6. 0.72727272 ... I can go ahead and eliminate an integer because this is not a whole number. Now I have the ... dots, which means that this continues, so it's not terminating. Decimals that repeat are rational, or do not repeat or terminate are irrational. If I look at these digits, they are the same. 72, 72, 72, 72. So I'm going to rewrite this one correctly. 0.72, and to show it repeats, I'm going to put the line over the top. So this is rational because it repeats. Just because it is not written correctly does not mean that that changes the rule. And we're on number 7. Number 7 says 8.9287364792 ... I'm going to go ahead and I'm going to rule out an integer. And then I'm going to rule out a repeating decimal because these digits are all different. And then because of these ... dots at the end, I'm going to rule out a terminating decimal because terminating means it stops, and these dots at the end mean that it goes on. So this is irrational. And again, I'm not going to write my reason because there's only one reason in 7th grade that numbers are irrational. And that's because the decimal does not terminate, which means stop or repeat. Now next year in 8th grade, there'll be other reasons, but for this year, there's only one. Number 8. Number 8 says 0.832. So it's not an integer. I'm going to rule that one out. It does not repeat. There's no line over any of my digits, and the digits are all different. My next choice is terminating. This does terminate because it stops. There are no dots at the end. There's no more digits. There's no dots. Like this is just it. It stops at the end right there. Like that's the stopping point. So this is rational. And it is rational because it terminates. Number 9. -3.3333333... My first 3 is a little ugly. Okay, so I'm going to go through my list. It is not an integer. It is not terminating. I know it's not terminating because of those dots. Those dots tell me this continues. Does it repeat? Well, if I look at the digits, are they the same? They are. It does. So let's write it correctly. I'm going to keep my whole number. and then I'm going to put a line over my first repeating number. So it is rational because it repeats. This was your last problem, number 10. Negative 4.01, 011, 0111, 01111, ... So I'm going to rule out integer. Also, because of the dots, I'm going to rule out terminating. Terminating decimals stop, and those dots mean it continues. So I'm going to check to see, does it repeat? So if I look at my pattern of numbers, I have 0, 1, and then 0, 1, 1, and then 0 with 3 ones, and then 0 with 4 ones. So it is very similar. However, it's not repeating the same pattern. It is repeating the same digits, but not in the same sequence. I have 1, 1, and then 2 ones, and then 3 ones. So it is not repeating. This is irrational. I hope this little review has helped. I do want you to take a picture of your notes and upload them in the review of 1-2 practice. On your notes, it should be headed up correctly. You should have drawn my umbrella graphic one time and one time only, and then you should have all 10 problems written and labeled as to whether they're rational or irrational or not. And if I labeled Y, you should have also labeled Y.